we talk about cloud computing where hundreds and hundreds of entities work together, but they don't have one thing to deal with. That's the policy and regulation. So, as implementers, they are doubly challenged to not only talk in terms of cloud computing and implement it in terms of smart grid, but they are also dealing with regulations and implementations and policies. So we have two very eminent execs from the two of the largest utilities here, and I'd like to welcome Randy Huston, who's the director for Excel for smart grid implementation, and they essentially provide power to about roughly 65% of Colorado. And Randy, it's all yours. Thank you.
Yeah, my name's Randy Huston. I'm had the privilege the last few years to work on our smart grid strategy and the implementation of Smart Grid City. How many of you here have heard of Smart Grid City? Okay. How many of you, before you came here, had heard of Excel? All right. Well, Excel is the fourth largest investor-owned utility in the United States. We also are the largest provider of renewable wind energy in the United States, and we're the fourth largest provider of solar. So we have quite a bit of background. And we just recently announced that we're ahead of schedule on achieving our goal of 30% of our energy provided from renewables that we set for 2020. And we think we're going to beat that pretty handily. This is what I just went through. We're across multiple states, basically through the center of the United States. About 3.4 million electric, 1.9 million gas, traditionally regulated. The company itself is, we've always prided ourselves, or at least in the last few years, on being an environmental leader. So we've worked very, very hard with many other parties to develop an environmental stewardship model. And we found that very successful, both in terms of for our rate base, for our shareholders, and for ourselves. So a few years ago, about 4 years ago, there was a lot of talk about smart grid, and what's smart grid, and so forth. Companies all over the world were starting to invest significant sums of money. Papers were being written. Everybody had a different definition. The only thing, there was an energy policy coming up with a new president that we saw coming. And so our company decided that rather than step back and just pick a piece and try it, that we basically try to build out a comprehensive view in one area. So Smart Grid City was a project where we partnered with a number of companies, worked with some cities, selected a city, which is Boulder, Colorado, and then built out much of the basis of what is a smart grid as it was defined at that time. So we were looking for areas of operational efficiency, reliability, conservation, renewable power. And one of the things we wanted to create was a demonstration site, something where it wasn't, let's try meters, let's try Volt VAR, let's try this, let's try that, but let's put them all together. We wanted to build our skills and experience to learn what worked and what didn't work. We wanted to prove and disprove hypotheses. We came up with about 70 hypotheses on things that if you do this, you'll get that, if you do this, you'll get that. We also wanted to evaluate benefits, things that, for example, that we hadn't thought of, but maybe they're out there, so benefits or learnings. And then we wanted to leverage our talent. So a lot of the problem with this type of thing is how do you get the engine moving forward? How do you get the right talent engaged? How do you get people to think differently? So we went to the city, we built out a complete new IT infrastructure, we built all new systems, we built in an isolated environment. We implemented a fiber optic BPL system throughout the city for about 46,000 customers. We put on real-time grid monitoring for all transformers and all the way down to the meter for everybody. We added much more enhanced visualization and reporting, because as you make the grid smarter, you're getting overwhelmed with data. So you have to be thinking as much up front about how do I use the data, what data do I need, as it is just getting the data. We put, we upgraded for substations, and the key there, and we'll talk about that, is what we call the smart substation, but it was basically moving the point from the EMS systems, the energy management systems, from a centralized location to much more of the substation being either able to or being in a position for making autonomous decisions. We put in smart metering, and we also implemented a number of smart customer solutions, such as portals. Question, how much detail does a customer need? How quickly do they need the data? How do you separate information that's been validated for billing versus raw information? Many things like this. So at this time, we're presently monitoring about 4,700 transformers, 23,000 meters, 4 substations, 4 feeders. The infrastructure is complete, all IT systems operational, security, all the data centers. We did about 100 new major interfaces, 23 major systems. Now, for the talk about, we also implemented a number of synchrophasers, grid upgrades, and other types of things. The total project to do the initial work took about 18 months for all of the pieces that you see there from conception to implementation. Since that point, we've been involved in a couple of different things. One of them has been refining the customer side, and the other piece has been analyzing. And at this point, we've developed about 150 different learnings, and we'll be getting ready to release our report on that information here in the not-too-distant future. From the, let's see, some of the key challenges, and I think these apply pretty much anywhere, whether it's in the U.S. or it's in your area. The managing the increasing amounts of data. The smarter the meter, the smarter the grid that you make it, the more information that's coming back. We went from roughly getting about a megabyte a day out of Boulder to getting a terabyte a day. We had to scale that back because, as you can guess, the exponential increase was unsustainable. But no matter what you do, as you make something smarter, you add more feedback loops, you take more information. And one of the biggest things you've got to figure out is, what data do I really need? Do I need to be setting thresholds? What do I need to capture? How long do I need to capture it? And who can have access to that information? Matt had talked about the privacy. That's been a big issue. Nobody cared about customer use until we could see it in very granular. All of a sudden, everybody that wanted to sell an air conditioner or something else wanted that information. So it went from having very little value to huge value. So this area of data, I really can't underestimate to you just how big of an issue it becomes as you deploy these systems. Leveraging of existing systems. We have one of the most advanced OMS systems, outage management systems in the world, but it's designed to use a combination of SCADA feedback and also call patterns coming in. It becomes self-limiting by the number of phone lines. As all of our devices come smart, they can inundate and overwhelm our systems. You either have to replace them all, or you have to figure out how you shield them from the inundation of the data and how you're going to handle that. The extracting additional value from the data, all of the information that you're getting, how do I utilize this? Is it worthwhile? Changing communications requirements. If I had to say there was one thing that, looking back, we learned a lot of lessons, but one of the big ones, a grid only gets smarter if you have a way to communicate, right? You can put out a grid that has manual reclosers and manual relays, but if you're going to have everything communicating, it becomes a communications infrastructure. And the biggest piece we're working on right now is, where are we going to go with communications? Do we want to communicate all the way out to the premise, or do we want to communicate to the subs? How do we secure it? Are we going to change our strategies? So one of the big learnings we did is, you can't have a smarter grid if you don't have a way to communicate the information. And you must develop your communication strategy in parallel with your grid deployment strategies. We looked at the IT business convergence. If you have IT systems and the business, just trying to get the two to talk. So for example, if you talk to your computer people, they're going to talk about 99.999% reliability. It means nothing to somebody. You want customer minutes out. So we've had to actually change our internal terminology so that our various groups can actually talk to each other, because they're becoming more overlapped.